So we're kind of thinking here about finding the area and the perimeter of these two-dimensional shapes, right? We're sticking in the land of quadrilaterals, specifically, mostly, or at least we're starting here with rectangles. Should be relatively familiar, right? You've kind of worked with some rectangles. Oftentimes we think of them like, we have this garden space. So when we want to find the area, how much we can plant inside of the garden, we know that to find the area of this inside space, we're going to multiply your length times your width. So what we can do is we can say, well, the length is, how do we get to the mouse? Okay, the length in this case is 12 inches, and the width in this case is 13 inches. And so the total area is 12 times 13, and we can do that in different ways. So we might remember we could always stack them, go to the traditional algorithm. Refresher, 3 times 2 is 6, and 3 times 1 is 3. It's not really a 1, it's really a 10. So we've done 3 times 12, right, which is 36. Then we can do 10 times 12 above it, essentially, right? But it's not really a 1, it's really a 10. So we have to put our placeholder there. And then this ends up being 10 times 12 instead of 1 times 12. We can do it this way with the algorithm. 1 times 2 is 2. 1 times 1 is 1. We see either way, we get 120. We add them up and we get 156. So the total area here is 156, and it's inches squared. And it's squared because we've multiplied two dimensions together, a width, a length. To find the perimeter, right? So kind of thinking now this was the area of the space inside of the garden. We have these different rows, right? How many rows? We can go kind of like this. We create these different units, right, to fill the space inside. Perimeter is like the fencing. So how much fencing would it take to go around this garden here? And to do that, that the sum, you're going to end up summing all of those sides together. Sum means to add. Answer to an addition problem, to be more specific. Answer to addition problem. 2L, so if we have the length, we're going to call the length 6. So we have 6 plus 6 equals 12 inches. And we have our width, we have 2 of them. 2 plus 2 is 4 inches. So in total, we have 12 plus 4 is 16 inches. And these are not squared, right? They're just inches. You didn't multiply anything together in order to get that dimension, right? It's just a single dimension. You're just having a length and a width and a length and a width and adding them up. The perimeter of this shape. So when we look at this one, I just moved it over here and stretched it a little bit, so it's a little bit bigger. So the perimeter, right, we're given all of the dimensions, so we're just going to simply add them up. We want to remember that when we're adding decimals, we want to really stack those decimals up so that they're lined up, so that our place value is all lined up. So we have 6.4 and 2.2, and I'm just looking for the ones in my mind. I'm looking for the ones that have decimals in them, and then I have 2 4s. And I'm just going to make it 4.0 and 4.0 so that they all are kind of in the same formatting, and we have 2 and 2. I'm just going to make that a 4. I'm going to add those right here. Okay. So then when we add them all up to find the perimeter, we simply just add straight down in our columns. 4 plus 2 is 6. I'm running out of space. And 6, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Okay, so we have 20.6. So the perimeter of the shape is 20.6. And we have to remember our units, inches. Not inches squared, just inches. Then if you want to kind of take it up to the next level, you can find the area of this, what we call composite figure, by breaking it up. So you can break it up into two familiar rectangles, right? We have this rectangle here, and we have this then rectangle here. Wow, that got crazy. So you do 4 times 2.2, right? Your length and your width. And you do right here, we're given that this is 4 times 2, right? So you'd have 8, and you'd have 8.8.